dividing fractions by fractions. In this, you can use one of the methods, but they're a bit more complicated. There's a nice trick that I like to use with something like this. So if you have a fraction, I recommend starting with the first fraction and drawing out 1, 2, 3, 4. So this is my 4/5. And I'm just trying to figure out how many 1/10ths fit inside 4/5. So I need to turn my fifths into tenths. And I know I can do that pretty straightforward by just making a swoopy line right across, because now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and now I have 10 pieces instead of just 5. Then we are counting how many of the boxes are shaded in. Let me switch to another color. So we have 1, 2, 3, 4, 5, 6, 7, 8. 4/5 divided by 1/10 equals 8. All right. One more. So this one's different just because instead of having a 1 in the numerator, I've got a 3 in the numerator. I can still start the same way. I'm going to want to start with my first fraction. So 1, 2, 3, 4. 1, 2, 3, 4. 4/5. I need to split the same way I did before. My fifths into tenths. And I can do that exactly the same way by drawing a line straight across. And now this time, instead of counting each square by itself, I'm going to count 3 squares as 1. So kind of like we did in the original red method. So 1, 1, 1. That's because of this 3 right here. 2, 2, 2. Uh-oh. If I try counting the 3s, I end up with leftovers. There's not enough to make 3 whole ones. So in this case, I would do a leftovers diagram also. I wanted to count groups of 3. That was my wish. But unfortunately, I only had 2 pieces. And so my leftover fraction is 2/3. If we put both of these pieces of information together, 4/5 divided by 3/10, I was able to count 2 whole groups and 2/3 of a group. Yeah, so you just got to pay attention to the numerators and make sure that you're not just counting each individual square by itself. Okay, I want to do one last problem for you. This one is from one of the homeworks. I think it was from homework 6.2.1. This question, don't worry if it's a little harder for you. This one, our review and preview, some of the stuff is review from the past and some of the stuff is preview for what you're going to see. So it wants to challenge you and see what you can come up with. You can absolutely figure this out right now, and I'm going to show you one way of doing that. But in chapter 7, when we get ways of dividing fractions without diagrams, it will become a much nicer problem. So I started by drawing 1 whole and 6/10. This whole right here, I split it into tenths still, so it is 10/10 currently. And the 6/10 right here, I'm blocking off these last 4 to remind myself that I can't use them. I can only use the first 6. So this is my 1 and 6/10, and I'm trying to see how many 3/4 fit into 1 and 6/10. So my recommendation for this to make your life a little bit easier is to create a common denominator. So 6/10 and 3/4 The least common denominator I can come up with is 20ths, which would require multiplying by 2 over 2, which would give me 12 20ths, and 5 over 5 would give me 15 20ths, so 15 20ths. So I'm going to need to turn my tenths into 20ths to make this work. So I can draw my line straight across. And now, this top line, instead of 10 tenths, I have 20 20ths available. And on the bottom, instead of 6 tenths, I have 12 20ths available. It's still equivalent to 1 and 6 tenths. I just wrote it differently. And now I need to be sure that instead of counting groups of 3, I'm now counting groups of 15. Well, this might take a little while. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 ones. I'm going to move along to 2s, see if I have enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hey, I did have enough. But I don't have enough for my 3s, not quite. So that means that I'm going to need to make a leftovers diagram. And in this leftovers diagram, it's going to be a long one. My wish was that I could have 15 3s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Nailed it. Unfortunately, my wish didn't come true. I was left with 2 instead of 15. So this fraction right here looks like 2 15ths. So 1 and 6 tenths divided by 3 fourths is equal to, I was able to count my 2's all the way through, and my leftover pieces is 2 15ths. Again, this one is definitely on the more challenging side. I probably wouldn't even put this as a Mastery Level 4 quite yet, but I do think it's valuable to expose you to this so that you are interested and you're wanting new and better methods. These diagrams work great and they help us understand where fraction division comes from, but in case you didn't notice, they take forever. And so we're going to want ways that are faster, but still help us understand the math behind it. So I hope you were able to find some part of this video helpful, and I hope you enjoy your weekend, and I will see you during class.